Hello everybody, and welcome to the definition at the bottom of page 13 in the workbook. This is going to be a very brief video that just fills in this definition together, and it's going to relate to part of the example that we did in the previous video. Okay, so let's read this together. If f can be made arbitrarily close to L by taking x values sufficiently close to a while always having x less than a, we write the limit as x goes to a from the left of f of x equals L. This is just a description of the concept of a left-handed limit that we talked about above. Okay, and the key is this x being less than a. We're just asking, what are the y values of our function approaching if we approach a from the left-hand side? Okay, and then we have an analogous definition if we're worried about the limit just from the right-hand side, where x values are bigger than a. In that situation, we'll write, as we did in example 1 above, the limit as x goes to a from the right of f of x equals L. Just notation to describe this concept. Okay, and again, these two limits are called the left and the right-hand limits, same terminology that we used in example 1. Okay, and then very important comment. Okay, the overall limit as x approaches a of f of x exists if and only if we get the same number from the left and the right hand side. Okay, in other words, if the limit from the left as we approach a happens to be equal to the limit from the right. Okay, you'll hear me use the word two-sided limit sometimes. Okay, when I talk about that symbol. Okay, so the two-sided limit exists only if we get the same number from both sides for a function. Okay, and we will proceed with some more examples.